Hello and good evening, CSI257 Section 847 students for the first 8-week term of the spring 2015 semester at Anne Arundel Community College. This evening's video tutorial is going to be on PacketTracer activity 8.2.3.5. And these are some of the most rewarding PacketTracer activities because we're going to be doing some troubleshooting here. And we're going to be specifically troubleshooting EIGRP for IPv4. As you can see, we have our addressing table information here, and really we don't know much about the issues that are out there, so we're going to have to do quite a bit of investigation to get us going here. So use testing commands to discover connectivity problems in the network and document them. Use verification commands to discover the source of the problem and devise an appropriate solution to implement. Implement each solution one at a time and verify the problem is resolved. If it's not, we may need to take additional steps. So let's go ahead and pull up our routers here because we know we're going to be doing some work on the routers. Let's make these give us a little more real estate to work with. Alright, that's router 2. Let's pull up router 1. And we will drop router 1 in here right now. And finally, let's pull up router 3. And obviously we'll be working with the PCs as well. However, the routers are probably going to be our primary components where we're going to be making the majority of the configuration changes. So where to begin, right? I guess we'll start with router 1. And let's go from user exec into privilege exec. And I'm simply going to type in show IP route. And so let's see what router 1 has set up. As you can see, router 1 is not learning any EIGRP routes, and we know that because the routing table here is not showing us any routes with a source of the letter D, which stands for dual, the EIGRP diffusing update algorithm. So we don't see any routes here. We do not have a default gateway either. And if we look here, chances are that router 2 should be the router that's configured to provide us with a default route. But right now we don't have any default route at all. So let's go ahead and let's try to ping that outside host. So I'm going to say ping 64.100.1.10. And as you would expect, since we're going off of our since we're going outside of the networks that we know about and that we have routes to, we're unable to get there. So let's do a show run, and let's go down to the section. First, let's take a look at our IP addresses here. Let's make sure our gig 00 is 172.31.10.1/24, so that's right. And then let's check serial 000. So the address that we show is 172.31.40.225, and that is a 252, so it's a /30, that's correct. And then let's check the IP address on serial 001, that's 172.31.40.233, and that is also /30, so that's correct. And then here is our EIGRP configuration. So as you can see here, we've got router EIGRP 11. Now this is interesting because up until now, we've usually used router EIGRP 1. So we're going to keep this here in mind. Our passive interface is okay, out the gig 00 interface, so that's good. What about our network statement here? Well, the first network statement shows a /24 for 172.31.10, so that's good. And then we have two /30s for 172.31.40.224 and 232, and these are both correct. So router 1, the only thing I see right now with router 1 that makes me a little nervous is the fact that we're using the autonomous system number 11. So I'm going to go ahead and make a small note of that right over here. So we're going to say device R1, and the identified problem, I'm just going to go ahead and mark it down, EIGRP 11. Proposed solution, change the AS, and let's see. Let's check and see, does router 1 see any EIGRP neighbors? Probably not, right? Show IP EIGRP. Oh, sorry about that. Topology. right? So we actually see some routes here. What about show IP EIGRP neighbors? And again, the routes that we're seeing there, those are originating with us, right? So those are from our two serial interfaces as well as our gig 00 interface. So we're not learning anything from anybody. So let's go ahead and let's take a look at router 2. So let's get out of the way first. Let's take a look at our interfaces here. So the gig 00 interface on router 2 is 172.30. Aha. So you can see right here that the addressing table shows it as 30, and now it's not clear, is that a typo? Because right here all of these addresses are 31. So all of these addresses, the same thing on router 3, they should all be 31. So I think that could be a typo in the exercise, and that this is actually correct as the default gateway for the R2 LAN. Well, let's pull up the PC, and the PC's address is even 172.31. So I am 100% certain, or I say 99.9% certain, that that right there is a typo. So let's check this out. So I'm going to ping, because it wouldn't be, if it was 30.20, then it wouldn't be the default gateway for this R2 LAN segment, where the PC's IP is 172.31. 2010. So let's ping 172.30.20.1. And we're having all kinds of problems here, so we can't even ping the default gateway. So let's take a look at our config here. 172.31.2010, 172.31.21. That is the default gateway. So we can't even ping our default gateway. Let's pull router 2 back up here. So I think that address is right, but we may come back and take a look at that. So the serial 00 interface, which is the interface to router 1, and as you can see here, it looks like there's a number of problems. So this shows 226 as the IP address, so that is correct, and this shows 229 as the IP address between 2 and 3. That is correct. And then we've got 209.165.201.1, and that is going to be correct. 201.1, that's correct. Okay, so everything looks good on the interfaces. So the physical interfaces look good. Aha. So now taking a look at router 2, what do we have here? You notice right away that router 2's EIGRP autonomous system number is not 11, it's 1. So I am confident that we are going to implement that step that we have listed over there for device R1, and let's do a show run, and we're going to have it print out. I think we just went right by it there. So I want to make sure we see this, because here's what we're going to do. We're going to remove, I'm going to say configure T to get into global config mode, and I'm going to say no router EIGRP 11. There's no way to simply just rename the EIGRP autonomous system by just basically saying router EIGRP 1. That's not going to get rid of 11. So we're going to go ahead and say no router EIGRP 11, and then I'm going to say router EIGRP 1. And now we're going to add back in our configuration. So I'm going to say copy, and then we'll come back down here and we're going to say paste. And as you would expect, take a look at that. We've got adjacencies popping up. And so now if I say do show IP route, all right, fantastic news. We've got our default route here, right? And remember, it shows up as an external EIGRP route because it is a redistributed static, and in EIGRP, redistributed routes are treated as external with an administrative distance of 170. And here is the feasible distance. This is the successor. So this is who I'm going to go towards to route this traffic, and that's router 2. This is how long that route has been in my routing table. And this is the interface out which, the local interface out which I'm going to go to get to that default route. All right, so now let's try this now. Let's say do ping 64.100.1.10. Can we get out now? All right, well, we're able from router 1 to get out. Let's see if we can go from PC 1 all the way out to the outside host. So we'll say ping 64.100.1.10. All right, so we've got connectivity there. So this is good news. So router 1 is now back in the game. If I do a do show IP-EIGRP neighbors, you can see that router 1 sees both router 3 and router 2 as neighbors, right? So this is good news. So we're going to go ahead and say end to get back to privilege exec, and I'm going to say write mem to save my config on router 1. So now let's go back up here to router 2. And I'm going to say show run one more time here. And we want to come down to the EIGRP. So we're redistributing the static. We have the passive interface on command on the gig 00 interface, which is what we want. But let's take a look here. We have the 172.31.40.224, which is the /30 between router 2 and router 1. We have a single network statement here for our /24, which is 172.31.20. But what do we not have a statement for? Exactly. We're missing a network statement for the transit network right here, this 172.31.40.228. So if I were to say show IP-EIGRP neighbors, I only see one neighbor, and the only neighbor who I see is router 1. Because if I were to say show IP-EIGRP interfaces, I'm only running EIGRP on a single interface, and that is my local serial 00 interface, which is this interface right here, that is connecting me to router 1. So what I need to do is I need to add in that additional network statement. So let's go into global config mode, where I'm going to say router EIGRP1, and we're going to go ahead and say network 172.31.40.224.0.0.0.3. Again, we're putting the wildcard mask in here, and this should bring up an adjacency. And I apologize, I just realized I typoed that. I was looking at the right spot, and then at the last second looked at router 1, and now I've taken the adjacency out. So let's put the adjacency back in for router 1, and we want 228. 228. There we go. And now it is, there we go. So we definitely want to take a look at what our EIGRP section looks like here, because I was all over the board there. Okay, so good. So we've got those 3 in there. So now if I say do show IP-EIGRP interfaces, we should see we have EIGRP running on 2 interfaces. Each interface is reporting a single peer, which we would expect because these are point-to-point links. So let's say do show IP-EIGRP neighbors, and I should see that I'm neighbors now with router 1 as well as router 3. And let's say do show IP route. So I've got my gateway of last resort. We have our static route right here, which we are redistributing. And again, if we were to go back up to the EIGRP config section, you can see that we are redistributing that static default route. Okay, so that takes care of that. Let me go ahead and type in. Let's save the config here, and let's try again from PC2. I believe we tried from PC2. Yeah, let's try from PC2, and let's see if we can get out to, let me try to ping 64.100.1.10. All right, so we've got connectivity out to the internet. What happens if I try to ping PC3 at 172.31.30.10? Can I get there? Let me make sure I get the IP right, 172.31.30.10. I can't get there. And now I can. All right, good. So it's working. So let's take a look, finally here, at router 3. So let's say show run. And if this was a real Cisco router, I'd be typing show run and piping it to, well, in fact, I've got a Cisco router right here. So let's take a look. So on an actual Cisco router, chances are you're not going to want to type show run, right? Because you're going to have to page your way down, right? Get through all the interfaces if you've got crypto keys set up to get to the EIGRP. If I just want to see the EIGRP, I would type show run section EIGRP. And then it's going to show me everything that has to do with EIGRP, and I'd be looking right here, router EIGRP. Okay. But with PacketTracer, I need to type show run. So here we go. So let's take a look, see what we've got here. So I've got the first network statement. Well, actually, we've got the passive interface statement out the gig 00 LAN interface, which is what we want. So now we have a network statement for the 172.31.40.228, and that's correct, /30. And then we have the 172.31.40.232, and that's correct, over to router 1/30. And then I've got the 172.31.30 for my LAN interface to advertise that. Now, we may have an issue here if I say, let me type Q to quit, and if I say show run, or I'm sorry, show IP route, and if I take a look in here, we can see we've got our routing table. We're learning the routes from 233, which is router 1. We're also learning routes from router 2. We're picking up that external route. However, when we look here at the tail end of that EIGRP configuration, we have auto summary enabled, right? Well, we don't want auto summary enabled because what is that going to give us? It's going to take these and it's going to look to advertise those as a single /16, right? So, and that's definitely something that we do not want to have is auto summary on. So we're going to go ahead and come over to router 1 here and let's take a look. If I were to say show IP route, what do I see? So it shows me the 172.31.0.0/16 is variably subnetted, right? And so we do see that we're picking up routes from router 3 on the 172.31.40, and the 233 shows it's directly connected. However, do I see the 172.31? And there it is. Okay, I was looking for it. I didn't see it the first time I came through. So here it is, the 172.31.30.0/24. So, but we want to turn auto summary off here on router 3. That way we're seeing the routes the way we would expect. So we'll go to global config mode. We'll say router EIGRP1, and I'm going to say no auto summary. And so we get a quick resync. If I come over here to router 1 and now do a show IP route, you can see that the resync did not negatively impact us, and we have the routes in the routing table now for the 172.31.228 as well as the 232, which is directly connected. So we have all of our routes in here, and as you can see, we've been able to successfully identify the 3 issues that we had in our EIGRP configuration. All right, so this wraps up PacketTracer tutorial 8.2.3.5. I hope this has cleared up any confusion and given you some clarity on how to troubleshoot EIGRP for IPv4. All right, thanks for watching, and I will see you guys on Saturday.